Hello everyone, welcome to Summer of HPC in 2020 Project 2017 presentation. I am Elman from Turkey and
I'm Jesus from Spain. During this summer of HPC, we have been working together at Surfsara, the Dutch National HPC Center. You may be asking yourself why this is relevant for an HPC center. To answer that question, it is needed to understand that modern HPC systems are very heterogeneous environments. There are different hardware solutions, with multiple processors and accelerators architectures. Different parallelization approaches are possible, like pure distributed memory, shared memory, hybrid GPU, and moreover, there is a wide variety of scientific software offered to the system users, and each program uses these resources in a different way. This heterogeneity can be a problem not only for HPC maintainers, that have to ensure that everything works smoothly and fast on their system, but also for users that don't know how to get the best performance out of the system for each application. In order to overcome this issue, HPC specialists use a series of automating tools and frameworks to monitor the different hardware and software components of the system and get the best possible performance without sacrificing maintainability. At Surfsara, one of the main used tools is Reframe. Reframe is a high-level framework for writing regression tests for HPC systems. It allows creating abstract and portable regression tests, separating the logic of the tests from the low-level details, like the hardware or configuration used.
in this project we used the Reframe framework to automate the testing of specific software and hardware components of Cartesius, the Dutch national supercomputer. The first thing we tested was the file system of Cartesius. File systems play an important role in a supercomputer performance. Because of that, it's crucial to make sure that the performance is reliable and consistent. This is why we created a series of the tests allow Cartesius maintainers to monitor the scale aspect of the system. We also worked on two of the most heavily used applications on Surfsara systems, NAMD and Orca. Given their extensive use, it's crucial to test them truly and answer these questions. Are the performance as good as expected and they are consistent over time, particularly after maintenance and new installations? Do they perform and scale well on all available hardware and software configuration available on Cartesius? What are the best options for users to choose in order to get the best performance? To that end, we created a large number of tests for different hardware and parallelization configurations, checking both consistency and performance. After that, we analyzed the results and wrote extensive guides that will be published on Surfsara user documentation very soon to help them run Orca and NAMD on Cartesius, but also which hardware and software configuration they should use depending on their needs to obtain the best performance out of Cartesius. This in turn will help users make a better use of the resources, increasing the throughput of the system. Moreover, our tests will be used to make sure new installations perform at the least as good as previous installations, and also to make sure changes in the system don't affect performance in a negative way.
Last but not least, we also tested and analyzed the performance of LiAlia, which is part of the COMP Biomed European Center of Excellence. The LiAlia developers of the PSC were very interested in understanding how a new feature of their program behaves on Cartesius, so we collaborated with them to obtain meaningful metrics from the execution of LiAlia. We find this case particularly interesting because, in addition to the already mentioned advantages for maintainers and users of using these automating frameworks, we also directly helped the developers to understand better how to improve their code. It must be noticed that for this part of the project, that is LiAlia, we based the analysis of the performance on the application of the methodology proposed by POP, which is also a European Center of Excellence. Particularly, we used the profiling tool Macau, recommended by the POP Center of Excellence, and we integrated its usage in the Surfsara workflow by creating a comprehensive guide on how to use it to follow the POP performance assessment methodology.